Okay, welcome back. We're finishing up chapter 4. This is chapter 4, part 3 on probability. And where we left off, we talked about the complement of an event, union of two events, intersection of two events, and mutually exclusive events. Complement of an event. Here we have event A. The complement of it, A superscript C, or a lot of times you'll see a bar drawn over the top, not A, would be anything that isn't A. So if this were heads on a coin flip, the rest of this box would be not A or tails. We were talking about the investments we looked at in the last video, Markley Oil. Event A might be all the events where Markley Oil is profitable. The complement of A would be all of the events in which Markley Oil is not possible. Union of two events. The union of events A and B is the event containing all sample points that are in A or B or both. So everything inside of these two circles, even where they intersect, those are A union B. Something is either in A, in B, or in both. The sample space is this big box. Everything outside here would be not A union B, or the complement of A union B, and we call that a Venn diagram. Here we have the case where Bradley Investments, we have event M, which is Markley Oil is profitable. C, Collins Mining is profitable. M union C would be where Markley Oil or Collins Mining are profitable, or both. M union C, here we have 10, 8, 10, negative 2, 5, 8, 5, negative 2, 0, 8, and negative 28. So we have 1, 2, 3, 4, 5, 6 cases in which Markley Oil is profitable. The probability of M union C is the probability of the first case where one or both are profitable, the second, the third, the fourth, the fifth, and the sixth. Here we've substituted those probabilities in. The probability of 10, 8 is 0.2. 10, negative 2 is 0.8. 5, 8 is 0.16. You can see that. We add up those probabilities and get a final probability of 0.82 or 82%. There's a 0.82 probability or 82% probability that either Markley or Collins will wind up profitable. The intersection of event A and event B is a set of all sample points that are in both. The intersection is just this colored section here where both A and B are true. The intersection of two events, this would be where both Markley Oil and Collins Mining are both profitable. There's only two cases of that, 10, 8, 5, 8. We add up the probability of 10, 8 with the probability of 5, 8. We substitute in 0.2 and 0.6 and 0.36. So there would be a 0.36 probability or a 36% probability that both Markley Oil and Collins Mining proved to be profitable. Now we're going to look at some laws. The first one is the addition law. Addition law provides a way to compute the probability of event A or B or both. Right there, we know that's a union, A union B. The probability of A union B is the probability of A plus the probability of B minus the probability of both A and B. We have to subtract out this probability of A intersect B, or A, both A and B, because that probability here gets counted twice in the probability of A and B. So we have to subtract that out to get the probability of A union B. So if you look here, the probability of M union C is equal to the probability that Markley oil is profitable, plus the probability that Collins Mining is profitable, minus the probability that both Markley and Collins oil are profitable. There's a 0.7 probability that Markley oil is profitable, plus the 0.48. Here you can see you've got to subtract something out because those are going to add up to more than 1. You can never have a probability greater than 1. So we know something else has to be done, and in that case, we have to subtract out the probability that both Markley and Collins are profitable, and that leaves us with a 0.82% probability, and that is the same as that obtained earlier using the definition of the probability of an event. So we could go back here and see that we got the same answer. Mutually exclusive events. Two events are said to be mutually exclusive if the events have no sample points in common. Two events are mutually exclusive if when one event occurs, the other cannot occur. This might be a Venn diagram for a roulette table. Event A might be that you get a black number. Event B might be the probability that you get a red number, but there are some numbers, 00 and 0 on the board, that are green. So this might be the event here, A, that you get a black number, B, a red number. You cannot get a black number and a red number at the same time. They're mutually exclusive. By getting one implies that you don't get the other. So if I get a red number, it's not going to be black. Those two events are mutually exclusive. If two events, A and B, are mutually exclusive, the probability of A intersect B is 0. There is no common area in this Venn diagram that is included in both A and B. Therefore, they're mutually exclusive, and we have a short rule here. If two events are mutually exclusive, the probability of A union B, the probability that something is A, B, or both, is equal to the probability of A plus the probability of B, because if we were to subtract out, like we did earlier, A intersect B, that's simply 0. So we're really subtracting this out, but because it's 0, we just ignore it when two events are mutually exclusive, and only when. If two events are not mutually exclusive, then we have to go back to this addition law and subtract out the probability of A intersect B. The only reason we don't when they're mutually exclusive is because we just know that this is 0 anyway. So if you have a choice, memorize the general rule. The special rule is nothing more than the general rule when the probability of A intersect B is 0. And that's only when they're mutually exclusive. Conditional probability. The probability of an event given that another event has occurred is called conditional probability. The conditional probability of A given B has already occurred is denoted by this symbol here, A given B. All right. So here we've got the probability of A given B. So B might be, that you make a sale. Say you're working in a business and B is that you've made a sale. So that's given. Given that you've made a sale, What is the probability, say, that a customer will buy product insurance from you? The formula for this is the probability of A given B. So the probability that a customer will buy insurance given that they bought a car from us, let's say, is equal to the probability of A intersect B divided by the probability of B. If you think about this, this would be the probability that someone has in the past, let's say, bought a car and insurance from us. And let's say 30% of all of our customers that come in the door have bought insurance and a car from us. Only 50% of customers actually buy a car that walk on the lot. 50% of them don't. So we would have 0.3, 30% of all customers buy insurance and a car from us, divided by 0.5, only 50% buy a car. 0.3 over 0.5 would be 0.6. So if you sell a car, there's a 60% probability that you should sell insurance to the customer as well, given that they bought a car. That's the important part. Here, using the Markley and Collins numbers we've been using before, we know that the probability that Markley and Collins make a profit was 0.36. The probability that Markley is profitable is 0.7. So here, the probability that Collins is profitable, given that Markley was profitable, we want to calculate that probability. The probability that Collins and Markley, Collins intersect Markley, are profitable is 0.36, divided by the probability that Markley was profitable, 0.7. We perform the math here, that's 0.5143. So the probability that Collins is profitable, given that Markley turned up profitable, is about 51.43%. Now, there's an easy way to remember the formula. Probability, Collins is profitable, given Markley was profitable. You see the C, the line, and the M. Insert a union, an intersection. You get confused. Insert starts with I, so does intersection. The probability of C intersect M goes on the top. The probability of the last letter, M, given Markley, that goes on the bottom. That's just a simple trick to try and remember the formula. You see this? We get rid of the line, put an intersect there. Insert an intersect. That is in the numerator. The denominator is simply the probability of the last letter, Markley being profitable. Multiplication law provides a way to compute the probability of the intersection of two events. The law is written as follows. The probability of A intersect B is equal to the probability of B times the probability of A given B. So you can go back here and see really that we're just doing a little algebra here. We're taking what goes on the bottom, multiplying both sides of this equation by it. P of M drops out on the right-hand side, so we have the probability of C intersect M. We multiply both sides by P of M, so we have the probability of, in this case, Markley being possible times the probability of Collins being profitable given Markley is being profitable. So we're just doing a little algebra off of that previous formula.